Episode 4, Asteroid Mining. You're listening to SPEXcast. Welcome to SPEXcast, a podcast for discussing the science and technology of space exploration. I'm Phil, and joining me today we have TJ.
Hello.
Augie.
Hello.
And Anthony.
Hey ho.
Today on the show, we'll be taking a look at asteroid mining. Yeah, so between Mars and Jupiter, there's a bunch of rock and junk that's basically a failed planet, right? And I mean, that's how I would interpret it. It's just a bunch of like stuff that we can use to turn into useful stuff. So we can take space junk and turn it into people junk. Right?
That is well said.
Okay.
Now, we have the asteroid belt, which is the largest collection of asteroids in the solar system. But when we talk about asteroid mining, as Anthony's probably going to bring up, near-Earth asteroids that are easy to get to, relatively close, are kind of the main goal for a lot of these plans. Anthony, do you want to get into that?
Yeah, so hi everyone, this is my first time on the SPEXcast. My name's Anthony Hennig, I'm a student here at RIT, if everyone knows. And I'm one of those weird engineers who likes public policy. So right now I'm in the master's program for science, technology, and public policy. I've worked in the field a little bit, the NASA Langley Research Center, which has been exciting. Just as an intern, nothing special. But that really got me excited about looking at space policy. So right now I am working on a thesis that's focusing on economically and socially valuable asteroid resource exploitation policy. Now, typically, you call this stuff space mineral resources, and that's what the International Astronomical Federation kind of classifies this as. But the whole idea behind space mineral resources is that the same stuff that makes up you and I, the same stuff that makes up the entire all comes from the same kind of collection of random junk. And the cool thing is the reason why minerals are so rare here on Earth is the same reason why we see this stuff out there in space. So there's a lot of great opportunity with it. The same kind of materials that we need to do things here on Earth are the same things that make up asteroids, that are the same things that make up us, which is really exciting. And looking ahead, there's a lot of new opportunities. So do you want me to talk real quick about like areas of interest? What are you interested in?
So,
yeah.
I am very interested in the technical methods of retrieving these asteroids. So you have, one of the popular examples is an asteroid that's mostly platinum, a very expensive element metal here on Earth. Now, it's rare on Earth because we don't have easy access to it, and the amount of it in the Earth's crust is very low. If bringing a giant chunk of that asteroid to Earth, how do they get it to Earth? Do they take a chunk out of it? Do we mine it there and bring back, the useful resources? Do we take the whole asteroid and do a little Armageddon scenario? Like, what is the most popular way? What are the pros and cons between these different situations?
So the field is still pretty deep in basic research. And something that playing off of what you just mentioned with platinum, there's some really interesting kind of technological growth. Like, how did this come to be? You see a lot of this asteroid mining stuff come out in around 2008. And when you look at it, platinum, $70,000 per kilogram. And that was based off of USGS and World Book prices. Anyone can look that up. It's gotten back down to $40,000 per kilogram. But when you think about it, it's like, $7,000 per kilogram. If you place that into context, the Atlas V, I think, operates at around $10,000 per kilogram to LEO. SpaceX is saying they can get it down to thousands. So we have this increasing or decreasing technological cost to do this. So it's making it more and more profitable. As for doing it, the general idea is to go out to a location, expend a lot of energy to get there, mine your resources, have some kind of CAMPOR unit. There's a really great kind of notional study out there from, I think, University of Washington. And you see this also with deep space industries and planetary resources. You get a big refinery, you move it to a location, you chew up the asteroid, you mill it, you sift it out, you heat it up in some cases, and then you bring back the stuff you want. And just the stuff you want, because energy is expensive in space. You gotta find energy somehow. So that's a general idea that most people are saying. So it varies.
Platinum may be expensive, but if you put it into further context and you look at, like, NASA has a mission called OSIRIS, which is
OSIRIS-REx, yeah, it's awesome.
Going out and actually retrieving a sample from an asteroid, and I think they're predicting 60 grams to 2 kilograms that they're going to return to Earth, and that's not entirely platinum, it's literally just asteroid rock.
Yeah.
And that's going to cost in total something like $1 billion. So
Yeah.
like, there's a lot of technical capabilities that need to be expanded on and that need to be a lot cheaper and more cost effective for the value of platinum to actually make mining in space.
So that brings up another point where you're looking for these payloads, and everyone talked about platinum to begin with because it was so expensive per kilogram. And if you look at the old asteroid redirect mission, it was planning to go to an S-type asteroid, bring back a big old stone.
What does S-type mean?
Okay, so yeah, there are 3 major types of asteroids that we see in the asteroid belt,
Right.
and there's a variety of other ones.
Is it based on size or what's in it?
It's based on what's in it, composition.
Okay.
And
So
that's expressed through its albedo and also its characteristic wavelength side of the results.
So S-type, I'm guessing silicon based?
S-type is it has a bunch of different metals in it. So there's 3 different types, like Anthony said. There's
Yeah.
C-type, which has tons of water and it's
Carbon,
high in
right?
organic
It's
carbon.
like protein powder almost.
Yeah. And then there's S-type, which has a bunch of different metals: nickel, cobalt, gold, platinum. And then there's M-type, which is very rare, but it has apparently 10 times more metals than S-type does.
Yeah, so it's kind of interesting to see how this all breaks down and how we can compare it to our own geological evolution. So C-type is the interstellar dust. It's organics, it's proteins, it's dust, water, it's a lot of stuff like that. When we look at S-type is like silicon, stones, it's things put into metal, or stones with metal imbued into them. It's a lot like the crust of the Earth. And then the M-type is almost like the planetary core that we have.
The mantle?
Yeah, the mantle.
Is that what M stands for? That's
Yeah,
not true.
yeah. Well, I mean, it's all kind of cool how it's all related. Like,
Yeah.
we came from asteroids.
Yeah.
But planetary processes took all the ferrophilic, the platinum, all the heavy stuff that's down in the core now.
Right, and that was as the Earth was forming.
Exactly.
The core kind of attracted it. And then, correct me if I'm wrong, but I think most of the platinum and the metals that we have on the surface of Earth's crust today that we mine mainly came from asteroids.
Yeah, so that's one viewpoint. There's a lot of correlation between asteroid impact location and richness of like materials. I'm going to try to find the study. You guys can search it online.
It's okay.
Oh, come on, I want to cite things though.
Okay.
I want to cite things.
You better cite us in your paper. How about that? That's the deal.
I think there is an
episode.
interview for APA. I'm going to cite myself in another podcast in my paper. Yeah, that works. Now I was thinking about citing. Oh, we found this book that was like the beginning of the space race. It was in like size 18 font. And I'm like written over very rudimentary, like the history of the space race and how it was all military for like 5-year-olds. Really wanted to cite that. I think I still might put it in there. This is like another historical. It would be like Kids Full Space Book. Why is that there? Okay, so yeah, so there's that one theory that a lot of people, it seems to make a lot of sense. We see that with like uranium and like radioactive and mineral stuff, which makes sense. When we look at some place like the Marinsky Reef in South Africa, that's actually like original crust. So you have the Canadian Shear, the Laurentian Plateau is another name for it. You have Marinsky Reef, you have parts of the Gobi Desert. When you radiocarbon it, it comes up to like 3.5 billion years old.
So that's like pure Earth,
Yeah.
not like contaminated with residues from.
Well, sifted.
Oh, okay.
It isn't turned over.
Right.
So think about it, like tectonic plates, they go underneath, they go above, things move up, things move down, things sift around. And these are places where it doesn't seem like that kind of geological activity took all the cool stuff, the metals and all that, and sunk it down to the core. So yeah, these deposits are called economic deposits because it makes profit. Because you can go there, you can apply technology to the ground, and you can get metal out of it. And you make money at the same time, which is awesome.
Yay!
But they aren't economic deposits, they become conditional deposits. That means if the technology gets better, or the costs drop, or something changes, then they might become economic again. But yeah, it's up in the air.
This sounds kind of like what might happen to asteroid mining. It seems like asteroid mining, like I'm trying to put all this that you're saying in context. So when we look at asteroids, we can only see what's on the surface, right? But if we send a probe closer or like impact it, we could then classify on a deeper level than just SMC. We could
and we
place them in deposit richness.
Yeah, and we can actually consider them conditional deposits. And what I try to get at in my paper is a lot of people, if you read 1997, John Lewis's Mining the Sky, amazing book about asteroid mining. amazing book about asteroid mining. It's very philosophical. It's very, this is the future on everything. But as we've seen technology change, as we've seen the rise of like CubeSats and small space systems, the rise of the private space industry with, Blue Origin, SpaceX, all these different groups, the costs are decreasing to access these conditional resources. And as we find out more and more about them, as we do this NEA detection, near-Earth asteroid detection to try to save the planet Earth, we also find potential sources of resources. So there's these major economic concerns that it's like, wait, we know where stuff is, the cost of getting there is decreasing.
So the main point is really to make these conditional deposits economic deposits so that it's worthwhile and cost effective to go there.
And from the public policy area, it's becoming more and more likely that this is going to just be a technological inevitability.
I have 2 ideas to sort of pick your brain on, or at least counter some of the things. Right now, heavy metals and rare earth metals like platinum and the stuff that's rare on Earth but maybe plentiful in asteroids.
Potentially plentiful.
If it is plentiful and we have the technology to go out there and easily get it, wouldn't that make the cost drop and therefore make it less
supply and demand side of it?
Yeah,
right.
So there's this major argument, and we haven't had a lot of situations in the history of the Earth where suddenly something very, very expensive becomes super, super cheap.
Right.
But we have some situations where there's a technology jump that allows us to suddenly access a large array of previously conditional resources. So there's some interesting parallels we can draw, like the 1849 gold rush. It wasn't just because we discovered gold, but we also had just enough technology to figure out how to get the gold. And that made it an economic deposit to go on the mine.
And did that cause a drastic decrease in the price of gold?
I do not know off the top of my head. I need to double check that. We've seen it with like aluminum, even.
Yeah.
Aluminum used to be incredibly rare, and then you had, I think it's a Holt process, or not the Barrett process.
The way of refining it that makes it super easy to get.
1898, yeah, you could pretty much make aluminum out of gold.
Right.
And that changed everything. And now we throw aluminum away.
Yeah.
So
now, another resource that's heavily commoditized, heavily based on supply and demand is oil. Right? In the end of the early 2000s, late 2000s. In the late 2000s, you had oil 100.
Oh, okay. 2000 to 2000.
Yes.
I'm like, dude, we'll see.
At the end of the last decade, right?
Awesome.
You had oil being over $100 a barrel. I think got to 130, and you had gas prices going up a lot, right? But with the advent of fracking, a new technology, you suddenly had all those conditional deposits of oil became economic deposits, and now you have oil prices a lot lower. Now, in the geopolitical sense, there's lots of other factors, but fracking is another example of that technology opening up new resources. Is there any application or parallel between that kind of jump in technology and with asteroids?
Well, I personally see some issues with your analogy. I know what you're getting at.
Yeah. And this is another reason why I definitely advocate for people to seriously think about it. Because when you look at the scale of asteroid mining potential, like 21 Latucha, I think it's an S-type asteroid. I reference it somewhere. I want to bring this up real quick just so I'm not being dumb. But 21 Latucha, it's like the 21st largest asteroid in the sky. If you assume that it's just 40% nickel iron, and to everyone else, like nickel iron is steel. That's what we use to build everything. If you look at 21 Latucha, it's 121 kilometers across.
Wow.
It's huge.
It's huge.
Yeah, Ceres is 975 kilometers across. It's a small world by itself. Last time I checked, I just got the Horizons data. So if you want to check out cool things about asteroids, check out JPL Horizons. It's an online database of all the asteroids and everything found. In 1986, we were dealing with like 2,000, 3,000 known asteroids.
Now we have like tens of thousands, right?
How many? How many do you think?
I'm going to say 15,000.
What is the lower bound for the diameter?
No, this is all objects.
Well,
all objects found.
We can put it on, I'd say, what, a couple 100,000?
It said started at 2,000, right?
It started at 2,000 in 1986.
Well, we'll say, what, 600,000.
600,001.
Ooh, August gets it.
Dude,
When I pulled the data,
1.2 million. That's mine.
oh, dude, I'm sorry. When I pulled the data about sometime mid-February 2015, so you can cite my source.
Okay.
Deal with it. 704,000 asteroids.
Wow.
If you want to see something really cool, check out Scott Manley on YouTube. He did a visualization of asteroid discovery rates. And you saw it out, and it starts at like 2,000, and then gets to 4,000 in about 5 years, and then it just keeps on doubling all the way up through 2012. And then the video stops at like 450,000. That was in 2012. We're at 704,000 now in 2016.
Is that because the detection technology got better, or just because
so
they're looking in the right places?
Something funny that I want to think about somewhere is 1998 was a really cool year for asteroids. Because in late 1998, Congress said, we want to discover all the big near-Earth asteroids that could impact the Earth. And for our radio listeners, TJ's smoking over here, because he knows what came out in summer 1998. Yeah. What came out?
Armageddon.
Armageddon came out.
Suddenly people are very concerned about asteroids destroying the world.
Yeah, so if you look at NEA detection, Catalina Sky Survey, and they just find near-Earth asteroids. And it's cool because as we increase our detection technologies, so think about when you started seeing the full spherical cameras, right? Mm-hmm. These guys were going through the same kind of technological revolution. They're getting better and better digital cameras. They're getting better and better automated telescopes, like what we have. We could go out and find an asteroid, who knows, with our own little telescope, because we have, at the consumer level, good enough detectors and good enough mounts to track and detect. These things are really dim. They're hard to find. They're small. Albedos for C through M-type range from like 20% to 40% of reflected sunlight, so it's darker than like the moon and everything. So yeah, hard to find, but really worth it.
And C-type is obviously even lower. Those are impossible.
Yeah, if I remember correctly, those are really, really low because it's the analogy I use is it's symmetry protein powder and talcum powder, which is really dark, hard to see. Just piles of dust. Yeah.
I have two things that might take this conversation in different directions.
Sure.
One is you mentioned getting to an asteroid and like mining it is expensive energy-wise. There's a lot of delta V that it takes to get from the surface of the Earth to these resources and bring them back. Getting from the surface of the Earth to LEO costs a lot.
Yeah.
But doing a transfer orbit to, say, the asteroid belt, or even meeting up with a near-Earth asteroid, is comparatively less expensive. So would it be more efficient to just tow an asteroid back into near-Earth orbit? Because, like, what if we set up a whole infrastructure in LEO with, like, mining craft and refineries and stuff?
And a space train to bring an asteroid?
Yeah, just use a train to bring the asteroids back.
Well, think about the mass differences. So what is delta V defined as?
It's momentum. I mean, it's the change in velocity.
Formulaically, what is it part of? So you have a mass ratio involved with delta V calculations.
Right.
And
so if you pick up a lot of mass on the way, then the price goes way up.
It exponentially increases.
Yeah. Okay, I didn't think about that.
Mass ratio. So one of the big ideas, and what's really exciting to a lot of people, is the presence of lava, either hydrolyzed in S-types or just there in C-types. Water is one of the most useful things out there. You can heat it up and you can make a steam rocket. So if you check out Mark Santor, he made a lot of papers in 2001 about asteroid mining. And he was like, oh, what a steam rocket. And that he just like based everything off of like, I go to an asteroid, I get all the ice, I shove it in my rocket, and then I get all the good stuff and I just take it back with me.
So the premise of that is using in situ resource utilization as fuel.
Yeah.
Could you harvest that down to hydrogen only and then make hydrolox?
You could break it down to hydrogen. You could use that in fuel cells.
Oxygen.
Recombine it to make hydrolox, or you could recombine it just to be chemical. You could pump the hydrogen through an NTR, which would make it easy and get really, really good.
But the key is to make those refining methods cheaper than it would be to actually launch that fuel from there.
Yeah, and to do that basic research.
Mm-hmm.
So you got to realize I'm coming from this as a public policy kind of person. I love the engineering and trying to combine the two. I don't have all the answers about this, but the idea is do all the heavy lifting out there so the things that you bring back are minimal as possible. That's a general sentiment.
Okay.
Now, do most of these proposals have the raw materials returning to Earth, or do they just go back into Earth orbit?
So it varies based on the company, and it also sometimes varies based on policy proposal. So one thing I want to ask your listeners to think about is that when we have these big engineering problems, that policy and engineering work really, really closely together.
Right.
I've seen a lot of different things. Planetary resource deep space industries, I think they mostly plan on keeping it out there and bringing back the good stuff to some kind of low orbital deposit. There's a lot of policies that say, like, anything anyone ever mines, we'll buy it off of you and keep it in the There's a lot of discussion about it. I can't really speak with confidence about any one answer, and it varies.
One thing I wanted to bring up, and I brought this up when we talked about going to Mars too, is privatization, like ownership. Do people own asteroids? If you mine it, you own what you get, obviously, but...
Yeah, that's a Space Act. That just came out in November.
Oh, really?
And what did that act say, basically?
That act said you can't mine anything that's bionic, which is really, really interesting.
Bionic?
Bionic. Oh no, bionic. Like,
Yeah.
You see like little cyborgs living on the asteroid.
So doesn't
like,
that...
this is our place.
doesn't that rule out pretty much all C-type asteroids?
So I need to look up the formal definition, but I think the use of bionic meant reformed to or given life. That's separate than organic.
I see.
Organic is typically used to talk about, and you can speak up about this, but carbon-based compounds. That's what
But that's
organic
not...
is.
You can have organic things that aren't giving life.
Yeah,
And
yeah,
then
that's protein powder.
Yeah.
That is not organic.
That's a little confusing because there's nothing out there that so far harbors life. So wouldn't that mean
Maybe it's
anything is fair game?
Preemptive policy, preemptive regulation?
Yeah, there's a major discussion about it within the international community. There are two major treaties, and you can look at, if you look at Dr. Ricky J. Lee, he wrote a great book called The Law and Regulation of Commercial Space Mining. He does a really great analysis. The last few chapters of the book will focus on his proposal from an authority, Men in Black kind of thing. It's actually really cool. The first few chapters are great if you're interested in this stuff. But he does a great overview. There's a few major policies that affect this kind of concept of asteroid mining. The ones that are small are like the Nuclear Test Ban Treaty, there's a Militarization Treaty, and Liability Convention. Stemming from that, you have two major treaties, though. One that everyone signed and one that nobody signed. And by nobody, I mean people who don't have a major space presence to begin with. 1960s, super interesting about like environmental concerns.
Yeah.
You have the beginning of the environmental movement. That's when you say Antarctica is off limits to everyone in 1963. Around 1967, you have the Outer Space Treaty. And the Outer Space Treaty contains 9 or 10 major articles about how do you conduct spaceflight. And you have to realize it came out at a period where, like, the Russians had just put a machine gun on their space station, and everyone's like, we're going to send our Marines to the moon, and they're going to deploy a base up there, and they're going to be doing push-ups and zero-G. And there was this whole big thing about militarizing space. So everyone kind of got together. They said, nations can't own anything. Because if you have a nation capable of taking the high ground, it could potentially close out everyone, which could be detrimental. It's the same thing with seas and Antarctica to some extent. Another major issue was like no militarization, like don't get to the moon, and then as like at the time the Soviets were like to shoot guns at them and everything. Don't do that. That's a bad idea. It's a terrible thing. They actually included a rescue agreement, which was really cool. It said pretty much if there's any spaceman in need of trouble, space staff, I guess.
Space. Okay.
You had to rescue them. So it was very noble. It was very Star Trek kind of like we need to protect the future of space. And so that's a major treaty that pretty much said nations can't own anything. Come around 1980s, or right before 1980s, you have the Moon Treaty. And the Moon Treaty, it intended to expand the Outer Space Treaty, and they intended to say that you can't have private ownership of anything in space. Nobody signed that. It was even under extreme contention here in America about signing the Outer Space Treaty, even though it was like, no one's going to shoot us, we can't shoot anything. I don't know.
Yeah, because the fear is over-regulating and preventing space exploration there as a result of that, right?
Not so much that, it was direct militarization.
Okay.
One thing I would like to challenge you guys to think about is, think of the imagery of spaceflight leading up to 1967. Okay, you had Star Trek, you had Living on the Moon, you had O'Neill cylinders, you had everything. And after that, it changed. There's a major discussion within the space policy community about the outer space treaty imposing some legal paralysis. You can make a big argument that wherever military goes, industries and nations can follow, and civilians follow.
I mean, because war and militarization fosters the production to make their resources and tools, and then you always want to have better tools than the other guy, so it promotes engineering and scientific development and research, and it can really, and that's what one of the reasons, it's one of the things that brought the United States out of the Great Depression was World War II, in my opinion. I mean, right?
And you can see that with the creation of the NSF, like Vanderbilt Bush, awesome like manifesto that created the National Science Foundation. It was, you got these military personnel, they're committed to the nation, they love doing things to help. We need to do science. Like, we can't get by with just riveting everything and like basic plane production. We can step it up now. We have a major technological boost, we have a major funding boost, we have everyone kind of aligned on the same goal. And this is a whole bunch more policy theory and everything, if you want to get a quick read. John Kingdom, Agendas, Alternatives, and Public Policies. But anyways, so it was a major pressure, and so like, did that change everything? So you could say, yeah, it'd be great, we'd be living on the moon, all this would be set up, but think about the flip side of it. You'd be living on the moon with armed guards, shooting down anything that got nearby.
Right.
You'd be shooting other telescopes and satellites out of the sky. What future do you want?
I think one of the big turning points of that is do we want to make other worlds like Earth politically, right? From space, you see Earth as just one object, land masses, but on all the maps that we usually deal with, everything's partitioned into states and regions. There's borders, and each state has their own rules. It was more of a question of, do we want to put that structure onto the moon and other planets, or do we think we can use that opportunity, the new frontier, to come up with something better?
And it also plays to that and the concept of the commons. That was the biggest thing. It said, res communis, that the space is the common heritage of all mankind. Everyone shares it. No one is allowed to overexploit. What they didn't expect was private space industry.
Isn't asteroid mining exploitation of the natural resource, though? Okay.
The outer space treaty talked only about nations claiming land. No one probably ever thought that, I wonder if this company that started by some guy in his backyard is going to go and mine an asteroid. That wasn't even a concept.
Kind of bringing this around from, that's people predicting or not predicting what would become of their future. Now we're here. What can we do today? What technology is out there today? There's already companies thinking about and forming plans and forming tech to mine asteroids.
And you just have the ALK-D3 reflight, which is starting to do technology development at the 3U CubeSat scale. They're going to plan a 6U that should launch sometime this year.
I'm not familiar.
In April. So basically, Planetary Resources is designing the spacecraft that'll go out and mine these asteroids, and they launched essentially a 3U CubeSat. The first one ended up blowing up on the orbital launch in October of 2014. Really? So they made a different one called A3R, which the R just stands for refly, and
the A is ALK, which is a probe droid from Star Wars.
Yeah. It's kind of a play on homage to Star Wars.
Acrid probe droids.
I can't pronounce.
It's a hard word to pronounce.
And so they're testing their ADCS, Attitude Determination Control System. Basically, this whole CubeSat tested all this stuff, and then it re-entered in last December, but we haven't yet heard anything from Planetary Sciences about the success of that. Although we have heard they're planning on launching a 6U this year.
Is there a CubeSat that's just telemetry and sort of scanning the asteroids for what's good and what's bad and ruling out what's
right? CubeSat's not even doing that. They're just testing, basically. It's their first thing that they've flown, and they're kind of testing their systems and making sure when they do throw a telescope and throw the infrared sensors on there that it'll be successful.
Yeah, it's just a full scale, and it's an interesting difference. So part of the outer space treaty, any data you collect, you have to disseminate. With private industry, no one's ever said,
Yeah.
Any data you collect in space, you have to disseminate.
Right,
And
and
it's
it
interesting.
kind of needs to be that way, though. It's kind of necessitated by the fact that if it has to be public, companies may not invest the resources to do these kind of experiments because they don't gain the benefit from it.
One question about planetary sciences, or planetary resources rather. Do they intend to have their final satellite systems and scanning ships and stuff that small as far as the 6U CubeSat?
No,
How big is it supposed to be? Like the size of a sedan or a school
So
bus?
everyone's using CubeSats right now. I don't know what the upper limit is. If you go to the Deep Space Industries websites, they want to. It's huge. It's massive undertaking, like ISS scale, variable
Oh wow.
in some cases.
For the refinery or for the mining?
For the refinery, there's a lot of different mission architectures out there. I mean, even if you look at Asteroid Redirect Option B, which is the flight of the asteroid, pick up a boulder and bring it back.
Mm-hmm.
I mean, that's bringing back a huge amount of mass as is. The beauty about space is a little bit of force over a long period of time to get you a fall rate.
Right.
So the size varies. Right now, everyone's kind of basing it off of CubeSat, which is really exciting.
And intending to scale up?
And intending to scale up. Because you don't want to build a whole satellite and then send it out and be like, oh,
That didn't work.
that didn't work at all. Like, yeah, we can't rendezvous with anything.
Yeah, that's kind of how I play Kerbal Space Program, so don't put me in charge.
Yeah, that's
Well,
all.
we'll try this.
Actually, that's kind of why I suggested doing this topic, is because I wanted to go to Duna, which is the Mars analogy in Kerbal Space Program. I ended up mining an asteroid by accident. Not by accident,
Oh, yeah,
but
mining an asteroid is so easy.
Can you do that with
It's
Kerbal Space Program for fuel? Is that the goal?
Yeah, it's awesome.
I was very surprised on how easy it is.
You just gotta hit it hard though, and drill into it.
If only it was that easy in real life.
Those
Well, it's actually pretty similar to what might happen, where you just find an asteroid, you kind of like scoop up bits of it,
Right, because
You
it's kind of
sift it
like
down,
clumped together.
and you sift it all out and everything, and then you're like, okay, cool stuff, like, done.
Yeah, but you have to harvest that for fuel, and then you have to actually put it in your propellant tanks, and that's the more complicated part.
And we're still figuring out how to do cryogenic propulsion transfer. It's
Sure. I mean, we can't even yet do that on Earth in a highly automated manner. I mean, I know SpaceX has made advances with that, and some companies they hook something up and it works, but we're not yet harvesting resources and then automatically putting them in our rockets. Like we are still far from that.
People are like, oh man, why can't we go to Mars yet? And someone's like, oh, bro, ISRU, like, oh, somebody's in the way, somebody's making it difficult. And it's like, you know what? I challenge you. Go into your backyard and make rocket fuel out of some gold. Like, just go for it. Good luck. You got it. You get it.
But
it's pretty hard.
So making it automated is really hard. But what if we sent a manned craft to do it and have a person help out?
Oh man, so there's some major policy implications about that.
What?
A lot of people have proposed that you have to be able to demonstrate you can send people back and forth. So
you have to make sure that it's not a suicide mission.
Yeah, you don't want to
bad.
You don't want to Mars one. You're actually no Moon. Oh, I don't want to give away too much. If you haven't seen Moon yet, stop listening to the podcast. It's a great movie.
Okay.
And it's about
He's killing off our listeners.
No. Then come back, like pause it.
Yeah.
Then come back. Oh, well, they may have already gone off and done it now.
Right. Oh, that's okay.
Anyway,
Welcome back.
Welcome back. I hope you watched Moon. It's a great movie. I didn't want to spoil it on you, but now I can.
Mm-hmm.
Right? That's enough of the spoiler.
That's fine.
Okay,
Yeah,
cool.
they're aware.
You don't want to moon it and just like send off planes to go do your mining for you and everything.
Why not?
Well, there's some ethical problems.
There's a lot of difficulties of cloning humans.
And then brainwashing them and sending them videos.
I mean-
to people. I feel like I'm spoiling the movie for someone. There's some major ethical concerns.
Thanks for putting that gently.
This is why public policy is here, because we have everyone who's like, well, we're just sending people there, and if they don't come back, that'll be fine. It's automated. It's like,
I mean, that's what I do with my Kerbals. My asteroid miner thing, that was manned. There were 3 people in that pod. It took 4 years to get to rendezvous, and I had to return.
Well, there are significant advantages to having manned missions because of the communication lag time.
Oh,
if
and
you
look
have
at-
a human there helping out the automated system.
Yeah.
And to our radio listeners, I'm looking at my hands. These are the best manipulators that have ever come out of any engineering process. Like, we can pick up stuff, we can turn it, we can signal with it.
And we can we can improvise.
Yeah.
And that was my point. So it would be incredibly useful to set a person there and have them help the machines do the thing. Like,
So yeah, if you look at Ricky J. Lee, he's like, everything should just be automated. If you look at someone like Rand Simbal, who's arguing for Space Time and Price Act, which he says like, we just want to take the Homestead Act and scale it up.
Projected in
Fantastic.
Yeah, which is it gets to the point. It gets to the point where he's like, well, I've done the math, and you have to have 600,000 square miles of lunar surface to scale the Homestead Act,
right.
which is 4% of the lunar surface. So 25 people could own the entirety of the moon.
Wow.
Yeah.
As long as I'm one of those people, I'm okay with
Oh, that's
it.
great. And that's why we have the Moon Treaty, so no one could run off and like own a chunk of the moon. There's some interesting implications about that, and policy is trying to deal with what if you do want to send people, what if you want to do completely automated. Most of these companies are looking at full automation. It's cheap. It's getting more and more reliable. We're getting better and better robotics and automated docking systems.
And if one of them dies, you don't have to have a funeral.
Yeah, and you don't also have to deal with killing someone.
That's what I meant.
Yeah.
That was.
You're thinking very much of the end case. There's a lot of middle points that was scary.
Sending the humans is also a big difficulty, right? Where building your spacecraft, automated,
oxygen.
all of those things. You have to have pressurized volume. You need all of your supplies.
Human SMAD, 2.3 kilograms per day propulsion of food.
Oh.
Just
Plus water, plus oxygen, plus all of that.
You can recycle parts of that.
But it isn't. Yeah, we just keep on feeding it. Sword and Green, the whole mission out. Yeah, oh god.
Another topic I wanted to discuss is with private space companies leading the charge and utilizing these asteroid resources. How do they get the capital? Right? You mentioned that Planetary Sciences.
Planetary Sciences back. Some of their investors include like Larry Page and Eric Schmidt from Google.
But
a lot of just billionaires.
They're trying to build an ISS-sized orbital refinery and other large refinery vehicles that they have to send out.
Mm.
The ISS is $150 billion total, right? How is a private new company, even with backing from Google, how did those companies go out?
I mean, the main draw is that people would invest with the hopes that they would get that much return in the resources. Like we were saying, there's all this platinum and all this.
Which is terrifying on a public policy side. When you promise literally the moon.
Well, what if you sold the spacecraft? What if you sold so what if Planetary Science says, okay, we've made this spacecraft that can mine asteroids. What if we sold it to you? You're taking the risk on, but you're also going to reap the reward when it brings back the minerals.
And that's what basic research is all about. So we've been prepping for Mars mission forever.
Mm-hmm.
And that has involved incredible amounts of ISRU, in situ resource utilization. So we've been developing techniques about how to take dirt and turn it into useful things. Mm-hmm. We have some really cool facilities on the ISS right now, like the metallurgy experiment, the microforge. It's so cool.
What, can you explain it real quick? I'm not familiar with it.
I don't know a lot about it. It's just like a little metal forge. It's got 2 induction plates. It floats like a little thing of molten.
Oh, cool.
And they also did it on the Wakefield facility, which was really cool.
Does it use lasers?
I think it uses induction. I don't know. I'm not familiar with the payload racks on the ISS, unfortunately. Mm-hmm. But, we have this basic research going on, and this is where public policy and engineering and technology all kind of come together, because you do this basic research, you figure out that, like, I can take dirt and I can put it into acid, and then I can, like, throw some dust on it, and then it becomes steel. Like, that's how we do things. We're like, I wonder what's going to happen if I put my chocolate bar next to this radar receiver, and you make mud waves. You have this basic research kind of outline. And this is a major aspect of public policy and technology and innovation is, how do you fund that? And then how do you ensure the person who is spending their time doing it gets what they get back? And we have things like pens. This is why a lot of people are actually arguing for an ownership right to asteroids. That it's like, well, if I'm going to invent the way to get out there, well, I'm going to get whatever I get. So yeah, it's all kind of tied in together. That we've been doing a lot of basic research to figure out how to take dirt and turn it into useful things. There's a lot more to do. We don't really exactly know how to take care of asteroids because we haven't ever done it before. Mm-hmm. Hayabusa, OSIRIS-REx, and then Hayabusa 2, which is outbound right now. They all just kind of like scooping a little bit off the surface, and that's it. We know that works. What is going to be necessary next? And that's why a lot of people like asteroid redirect option A and option B. And I guess option C, what it is now, National Advisory Council just changed it last week, is instead of going to an asteroid, it should go to Phobos.
Wait, really?
Yeah.
I didn't know that. Okay.
You should check
so
it. Yeah,
basically, the asteroid redirect mission isn't happening anymore?
Well, it's probably going to go somewhere else. I just saw the quick.
Okay.
If you want to check American space, I think they
on the Mars vs. Moon podcast, I was kind of talking about how I think NASA should focus more on the asteroid policy because that could be a big milestone that they could hit before we head to Mars.
Oh, that was a big thing about option B. If you read Dan Mazinek's paper,
Okay.
I will full disclosure. I met him. He was in the same branch as I was when I was at NASA. It was all about. There's some major industrial applications for bringing back a boulder and doing all science, because that's part of the Outer Space Treaty, that if you bring something back, you collect your science, you disseminate that, and then saying, hey, we got a floating rock in distant lunar retrograde orbit, who wants to fly up to and like go to town on it and see what happens.
Sure. Yeah, so, I thought that was a great idea. Well, I mean, if they make it to Phobos, that'll be awesome, but...
There's a major discussion about should we have destination-based policy or should we have like technology-based one.
Have you guys played Space Engineers?
I've played Space Engineers. It's Minecraft in space.
It's not. I mean, it's more advanced.
It's better now, but it was just
still
Minecraft in space.
But
so
yeah,
is it like in C2 resource utilization where you make things using asteroid resources?
The idea, or at least the genesis of it, is you're in an asteroid field, and you start out with a welder, a grinder, and a drill. You mine different elements from the asteroids. So like they're randomly generated. They've got ice, iron, silicon, all these different elements. And then you can build refineries and automated assemblers, which build components which are required to build certain different components that you can make into ships. So
just start a company to do this.
In real life?
Yeah. Basically, it's like when I was thinking sending people to asteroids, Space Engineers is that idea made into a game.
The physics of Space Engineers is much more conducive, where you can just take a power generator and connect it to an engine, and then it just accelerates you. That's so much easier than real space.
It's really hand-wavy, but if you're interested in this sort of thing, playing Space Engineers is kind of like what Kerbal Space Program is if you think going to, like, reenacting the Apollo missions would be awesome, and then you play Kerbal Space Program. If you think asteroid mining would be awesome, you play Space Engineers.
I think
yeah, but you also need to have like a policy mod. So every time you put like an LTG,
you have to submit a request.
No, yeah, if you want to put an LTG on a craft, like you drag it, and it's like you sure you want to do that, and then you need to appropriate funds through the Department of Energy to produce a uranium 245 to be made into graphene blocks.
And then you have to have a design review, and then you have to present that, and then you have to get funding, and then you have to get a grant and write the proposal.
The United States hacks your uranium reactor, and the whole thing blows up.
Yeah. And then you're outbound to an asteroid, and then you get like a little message, and it's like, you can no longer own an asteroid. The national government. You need to fund private space industry. So now the game assaults its own separate game inside of the game that you have to fund. And it goes and does its stuff.
You're just a little lobbyist running around Washington.
And yeah, it just gets so meta. You're just one guy lobbying for things.
I think games and sci-fi kind of push real science, though. It'll be interesting to see in the future, like what kind of stuff like comes out of these games that end up being implemented in real life or driving the policies in real life.
Yeah, we are going for this golden age, right? Like KSP. Like, we know about Pulse Robotics. I mean, I did it back in high school. Did any of you guys do Pulse Robotics?
We didn't have a team.
I didn't have a team, but
I did the Lego first.
That thing is pretty awesome. But, like, we're having more and more people get exposed to technology in an early age. You know, you can have an argument about the STEM crisis or the STEM overage. Everyone sees it different ways and everything. Mm-hmm. And I think, but every one of us has played KSP. Mm-hmm. I was just talking to another member of Specs over today. I think we've all played KSP or been exposed to it at some point.
Yeah.
Like, when the group was founded, it was just at this time with this thing called KSP that everyone was getting excited about. Mm. And I think it's getting a lot of people excited about. And I think maybe the rise of CubeSats, the rise of these kinds of super in-depth games, maybe it's all connected.
Yeah, so KSP is really accessible to any range of people, like people that are middle-aged, people that are teaching their kids that are 4 years old. I've heard stories of all of those. Plus, the whole idea of makerspace, and like you can 3D print stuff, and there's Raspberry Pis, and you
can buy tiny little chips.
For $30.
Yeah.
And so CubeSats, getting them into space is the hard part. But yeah, we know that better than anyone.
Glad I don't have to. Oh wait, I will. Never mind.
But my point is that not only are people more aware and more interested, especially since SpaceX is having live webcasts for their launches and like teaching people what the ship is doing and explaining things as they go on, and then SLS is coming up and The Martian, and everybody's getting really excited, and it's becoming much more accessible for people to participate.
The craziest news story that I read, it was a little bit of a little meta policy analysis, was looking at the use of music in space movies. So 1998, Armageddon, Event Horizon, Deep Impact was off, very scary and everything. When you get after 2010, you have Gravity, which is space sucks, but people can survive in it. We have Interstellar, which is we can go to space to survive. We have Guardians of the Galaxy, which is nothing but disco. The same thing that we see in The Martian, which is nothing but disco. and it sounds pretty dumb, but somebody was making the argument. I don't remember who wrote the article, but you can search it out there. But it was like, we're not treating space with kind of whimsy. Because it's getting people to go there, and everyone probably knows someone who's been part of the CubeSat team.
Yeah.
Or somebody knows somebody who's been part of the space industry.
Right.
And it isn't so crazy anymore to think about it. It's like, my GPS, my phone connects to a satellite to get timing data to calculate its position.
Dish TV.
I get my television via Dish TV. Like, it's becoming more and more connected to our modern life. It's really economic, it's really profitable.
Hopefully tourism too, with Blue Origin and even Virgin Galactic.
Export, don't forget Export.
Oh yeah.
Oh Jesus.
But hopefully that gets people not only interested in space and being engineers and getting us to other planets as humanity, but getting people interested and involved in thinking about how, like, there's a thing up there that I can look at, and that's through my telescope, and it's an asteroid. Well, maybe not because they're dim, but you know what I mean. You get my point. And think, how can we use that? It's like closing the gap.
Yeah, and it's something that we have done over and over again. Like, think about it. We have moved as a species to find the resources. So there's three things that you can do when you're running out of something. You can be more efficient with how you use it. You can find an alternative. So if like you're running out of steak, you go for chicken. I don't know, something like that. Mm-hmm. Or you can find new resources. So think about it. We got out of sub-Saharan Africa to go find more meat, and then we followed that meat all the way down into North America. Then we got stuck there. Lots of us got stuck there. It's like, oh, whatever, we'll survive where we are. And then some of us from one part said, I bet there's something over there that I want, so we come on over to the New World, we discover Spain, tobacco, forest trading, all this kind of cool stuff, which is a whole other set of resource rush policies and issues in and on its own. But we have constantly said, like, I want more of something that I don't have here. I'm going to go find someplace else that has it.
Yeah.
And so with decreasing costs, with improving social demand, like, maybe asteroid mining is the next step.
I was going to ask, it seems like the policies that are being made, alongside the technology that's coming online, people are being conscious. As we kind of think about these things and businesses start up for asteroid mining and we can get closer to the asteroids, we're learning more about them, policies are coming online.
Yeah. Or we should have policies in place, just in case. Just in case.
In the policies that are out there, are people looking at how land and resources were exploited in the past and trying to prevent that?
That's what I'm doing for my analysis.
So I guess that takes into account the biotic stuff. Is before there might have been indigenous peoples, where what if there's indigenous bacteria on an asteroid? Is that the...
Think about it like that. I'd be looking into some of that. I haven't looked into it just yet.
Or is it just because we don't want to mess with potential new viruses that are on asteroids?
Yeah, I think part of it is planetary protection. Like, you don't want to mess up our planet, and you don't want to mess up their environment. And it's back to the commons. If you were to go out into your backyard and you found like some kind of tablet that talked about the whole history of mankind all the way back to 12,000 BC.
Mormons?
What?
No, he looked into a hat.
No, that was after. He went out to the forest.
Oh
and
yeah,
dug up
yeah,
a
yeah,
tablet.
yeah. I remember
With
what
the
you're talking
history
about.
of-
Yeah.
But
back
if you
in-
actually found a tablet.
But yeah, think about it. Like if you went out
iPad.
and you found a tablet that was like, this is the history of all life on planet Earth. Like, whose ownership is that? You listen to Indiana Jones? It belongs in a museum. You know, like, what do you do with that? And I think that's partially why that policy was put into place. Like, if you go out there and you find, like, a trilobite or a tribble or whatever, and it's like this product or what could come out of life on Earth.
But the fear is that may take away from the benefits of going out there and spending the money to.
But then
reach
again,
these
you
things.
might have also found the beginning of all life in the solar system.
Yeah.
And that is a hard thing to put a cost assessment
Two
on.
sides of
With
looking at it,
the talk of planetary protection with Mars, right? That's brought up a lot. Is that there
Viking was
Mars,
like guys in t-shirts.
like Mars had liquid water at one point.
Mhm.
Yeah.
There might have been life, and there might still be life on Mars, not on the surface. Now we're getting to that point in the next couple decades of active humans on Mars. Do we hold off from that with the chance that there's life on Mars? Do we check every possible location? Because, Mars is a big planet, so a lot of land, and if this life is underground, we might never be able to check every place that life could be.
So check out NASA Planetary Protection. They've got some good guidelines about it. It's one of the elements of the space policy is kind of preserving the space environment. That's part of the National Space Policy 2010. Check it out. It's really useful. Why are you going to Mars? You're going to Mars to do science. So if you go to Mars and then you say, boy, there's a lot of science here, I'll just pick it up and stomp on it a couple of times. That's not very good science. That's kind of the idea. Right now we're still in exploration.
True.
Do responsible
But,
science.
That's a good way of putting it. Like an archaeologist almost. That's what
Right.
Mars is. It's an archaeological dig site. What happened? Where did all the good stuff go? What's going on?
Curious.
But tying this in with asteroids, like OSIRIS-REx is a scientific mission to an asteroid, but all these planetary asteroid missions are going to asteroids for economic reasons.
Right.
So if you go to Mars, a NASA Mars mission might go there for scientific reasons, geology, chemistry, right? But down the line, when people want to settle Mars or use the resources of Mars, then it's the scientific value is not the main priority.
I'd like to flip
that's
that
really
perspective.
far out. Yeah.
I'd like to flip that perspective because this whole time we've been treating asteroids like dig sites and not even considering the way we're not looking at it in the same light that we look at Mars. Like,
Well, they're very different.
how?
They're incredibly different.
But why do we see asteroids as resource rather than scientific opportunity?
Asteroids are far more abundant, you know what I mean? And there will almost always be more asteroids to explore. We really only have one Mars planet, which is the most likely site of eventual colonization for humans.
And there's also like this interesting concept in public policy called aquaforums, and it's about you can't own water that's flowing. And so one interesting image that I've been working through is kind of like asteroids are like fish. There's a lot of fish in the sea. You can't overfish. You can't screw that up. We're discovering so many asteroids, so it's kind of ridiculous.
Right.
And so maybe there's a discussion about that where we see asteroids as these kind of like tiny rocks just floating around and everything. But Mars is property. Mars is a homestead. It's a land. It is a place to be owned. It's a circle, a sphere, with an atmosphere. An asteroid is really just a debris of thousands of destroyed protoplanets or things that never got off the ground, just dust grains accumulated over time.
Right.
We're comparing like a house to the dust bunnies around the house and in the house.
I see your point.
Yeah, maybe there's this mental image difference.
With Mars, there's a lot of inherent scientific value because it had active surface water, it has geology. We can gain a lot of information by just studying the state of Mars because it might have all the same materials as an asteroid, but the complete unit of Mars, as being that large planet, has a lot of features that a small asteroid doesn't have.
The essence of Mars,
Yes.
is different than the essence of an asteroid.
Okay. Thanks,
That's
Frank.
so philosophical.
I know. I love it.
I can't.
Why?
I'm joking.
We've been talking for about an hour now.
Yeah.
It's fun.
Yeah, there's some really cool books out there. Check out Space Policy Online.
If you could give us an email list of these books, we can put them in the
Yeah,
show
'cause we
notes.
could throw 'em- that I think is a great idea.
I'm gonna
Because
Even the games too is not a bad idea.
I just
Yeah.
hear so many podcasts and the guys are like, it's the future of mankind. And it's like, yeah, it kind of is, but there's some good reasons behind it.
Well, that's the end of episode 4 on asteroid mining. Thanks for listening. We'll be back next week with another discussion on space exploration, science, and technology. If you'd like to share your thoughts on asteroid mining or have requests for another discussion topic, send an email to SPEXcast@gmail.com or tweet to us at RITSpecs with the hashtag SPEXcast. If you want to hear more, consider subscribing to us through iTunes or your favorite podcast app. All past episodes are also available for download from our website, wiki.rit.edu/display/specs/SPEXcast.
Starting out.
This podcast is made possible by RIT Specs, a space exploration student faculty research organization at the Rochester Institute of Technology. Special thanks to the Interactive Learning Grant Program for giving us the tools to promote student and faculty engagement outside of the classroom. Our music is by Kevin Hartnell. This has been SPEXcast. We'll see you next week.